Look at this diagram showing intersecting circles P and Q. Our objective is to determine the equation of the common chord, CD, even without labeled axis coordinates. Every straight line equation requires two components, the gradient and one coordinate point it passes through. The problem statement contains geometric descriptions that provide the data needed to establish these two values. We begin by looking at the standard algebraic equations provided for both circles. To find the coordinates of the centers, we isolate the values inside the brackets and reverse their signs. This gives us center P at 0, 1 and center Q at 5, 4. Using the coordinates for P and Q, we calculate the gradient of the line connecting the two centers. By dividing the change in y by the change in x, we find the gradient of line PQ is 3/5. How does the gradient of this center line lead us to the gradient of our target chord, CD? The problem specifies that line PQ bisects chord CD. According to circle geometry theorems, a line passing through the center that bisects a chord is always perpendicular to that chord. For perpendicular lines, the product of the gradients must be -1. We take our gradient of 3/5, find its negative reciprocal, and arrive at -5/3. That is our first requirement completed. This illustrates how geometric terms like bisect function as direct instructions for finding perpendicular gradients. Now we need our second component, a coordinate point on line CD. To find it, we look at the statement that QD is a vertical tangent to the circle at point D. By definition, every point on a vertical line shares the exact same x-coordinate. Since point D is positioned vertically relative to center Q, and Q's x-coordinate is 5, we know point D must also have an x-coordinate of 5. Point D lies on the circumference of circle P. With its x-coordinate established as 5, use the equation of circle P to solve for the corresponding y value. Substituting 5 for x gives us 25 plus y minus 1 squared equals 25. Subtracting 25 from both sides and taking the square root leaves us with a y-coordinate of 1. We have now identified point D at 5, 1. Using the properties of vertical lines allowed us to derive a specific coordinate point from a geometric description. We have gathered our necessary values, a gradient of -5/3 and the point 5, 1. By substituting these into the point gradient formula and simplifying, we find the final equation, y equals -5/3 x plus 28/3. Our strategy treated geometric descriptions as translations. Bisecting a chord indicates perpendicularity, while vertical lines indicate shared coordinates. Conquering multi-layered problems depends on your ability to translate geometric conditions into actionable algebraic data.